Okay, hi everyone. Today you're going to watch this video to go along with your 8-7 homework. So your homework for tonight is to watch this to learn about paired data. Now this is something you actually already know something about from the beginning of the year. So let's look at the question that you have on your homework. This is question 4. It says one indicator of physical fitness is your resting pulse rate. What that means is if your heart is at rest and you have a low pulse rate, that means you're healthier because your heart's a muscle and it's actually resting. 10 men volunteered to test this exercise device that was advertised to increase physical fitness by lowering their pulse rates. Their pulse rates in beats per minute were measured before the test began and then again after. If you recognize this before-after situation, maybe from the beginning of the year. So before using the device and then again after. The results are shown here in this table. Are there one or two samples here, and how can you tell? Well, we do have before rates and we do have after rates. But there's really only one sample here. We only have one sample, and the one sample that we're looking at is 10 men. This is what we call matched pairs. If you remember that before-after situation from the beginning of the year when we did experiments, we paired people up to be as similar as possible. Well, here, our pairs are actually just each individual paired up with themselves. So if we want to answer the question below, to create and interpret a 95% confidence interval to estimate the difference in the mean resting pulse rate. So if we want to estimate the difference in the mean resting pulse rates, well then what do we need to do first? We're actually going to have to calculate all the differences to see, did this actually help? Okay, so if you look, if we were to start to compute these, I would say, okay, let's see, 73 minus 73, there's no difference. 83 minus 79, 4 beats per minute lower. 85 minus 81, 4 beats per minute lower. So what I actually like to do instead of doing the subtracting by hand is I go to my calculator and I fill in both my lists. And once I have both my lists filled in, you might want to pause here to do this. I have go up above L3, so you have that black box, and hit enter, and I'm going to have my calculator do this subtraction for me. So I hit second L1, and I'm telling the calculator do L1 minus L2. So I'm above L3 up here, and then you'll see it fills in all those subtractions, so I don't even need to think about it. So I do have those differences, so our goal here is to create and interpret a 95% confidence interval. So when we see the words confidence interval, we think of those steps of panic. So P, what's our point? Well, we're going to start by saying we wish to estimate the mean difference in pulse rates. We wish to estimate the mean difference in pulse rates. So our second step is to check our conditions. Let's check up here again. Did it say random sample? No, it's actually not random. We were told that we have volunteers. So when we have volunteers and not randomness, what we have to do here is assume. So we're going to have to assume that these men are a good representation of all men. If they're not, then this might not be a really good interval. Our second condition is independence. Well, 10 men is definitely less than 10% of all men, so we can assume that their pulse rates and their health are independent of one another. We don't have friends who are workout buddies. We don't have guys that are related. 10 men is definitely less than 10% of all men. And our third condition is nearly normal. The box plot. We need to make a box plot here because our sample size is only 10 and we have the list. So to make that box plot in my calculator, I'm going to go second y equals. I'm going to hit enter. I'm going to turn that plot on. I'm going to choose a box plot with outliers. And I'm going to tell the calculator that the list I'm looking at is list 3. It's the differences. Okay. And when I hit enter, I'm going to tell zoom 9. There's our box plot. So what I'm actually going to do here, you're going to sketch it. I'm going to have you draw it. So if you can't see the sorry about that. If you can't see the numbers on it, you can hit trace on your calculator. So if we hit trace right now, you can see that the minimum is -1, Q1 is 1, the median is 3, Q3 is 4, and the maximum is 8. So this is actually a box plot of the differences in pulse rates. It's not just the pulse rates, it's the differences. And if you look at this, you would say they are nearly normal since the box plot is roughly symmetric. Okay, so our 3 conditions check. We have randomness, we're going to have to assume, independence we have, and the differences are nearly normal. If you look from your median to your max and your median to your min, it's roughly symmetric. So since conditions check, we're going to create a 1 sample t interval for means, and our degrees of freedom is our sample size minus 1, so we have 9. In our calculator, to calculate the interval, we're going to do stat test number 8 for t interval. I'm going to tell my calculator data, but I have to tell my calculator list 3 for the differences. We were asked to create a 95% confidence interval. I'm going to hit calculate. It takes a minute longer. And we have our interval come up 0.99027 to 4.6097. So then to actually interpret our interval, we're 95% confident. The mean difference, it's all about the differences. That's why we did that subtraction. Impulse rates is between 0.99027 and 4.6097. Okay, so what we looked at here, just to recap, is we looked at the differences. We had paired data, but it's still only one sample. And so what we did was we looked at the difference between before and after for each person. So this was the one list that we used to do all our inference on. Thank you for watching this. I'll see you guys on Monday. Enjoy your weekend.